Hello viewers, welcome back to my channel. This is John from Cloud Tech Insights. In today's Sagemaker versus Bedrock session, we'll be talking about the fine-tuning techniques, how the features fine-tuning between Bedrock and Sagemaker. Compare both and see what best fits your use case. And also, we'll be giving a small introduction on what is fine-tuning and why do we need fine-tuning, and a couple of techniques that's been used in fine-tuning and where the trend is heading as well. So without much talking, let's get to the session. Before moving on to the course, I want to make a quick reminder on my course on Amazon Bedrock, published on udemy.com. I have provided some insights into Amazon Bedrock and some design principles on architecting solutions on GenAI on Bedrock. This course is good for beginners and intermediate level folks and who's aspiring for a career in AI. Without much discussion, let's move on to the session. So let's start with why do we need fine-tuning? So we have the options like RAG for all the knowledge bases, all the documents that have all the information that the LLM needs to respond to an end user. So let's say an end user comes and asks a question, it can pretty much use the RAG methodology to access the knowledge base, get the information, and provide the end user that information. Take an example, there's a paper on, let's say, theory of relativity, and you're using a foundation model to understand the paper, and the paper is the knowledge base. And then you want to try to understand using a basic foundation model. Let's say you pick up foundation model from open source, all of the models that is provided by a vendor. You use that to read the paper, understand the paper. But in that situation, the analogy is it's a regular person with regular education reading a theory of relativity. Whereas if you want to get better answers, understand the nuances between the area of physics, that person needs to be a physicist or somebody who has a background of physics. So that is where the fine-tuning comes into picture. So regular person becomes the foundation model, but if you fine-tune the model into more like a physicist side, where the foundation model understands the nuances between the terminologies between physics and the other theories around physics, can answer some of those theories much better. So this is the difference, and this is why we need to fine-tune the model. But I would say around 60 to 70% of the use cases, you don't need to fine-tune. But if you need to fine-tune the model, then you think that your use case needs that particular domain knowledge. So there are a couple of ways that you can fine-tune the model. The first method, which is very famous, is the regular fine-tuning, which is more of boiling the ocean, which means when you have to host the huge LLM onto CPUs or GPUs based on the model, and then you can start sending the information to the model, and based on the training, it basically changes all the weights within the model, and model becomes completely new. It's a high risky, high resource intensive, and unpredictable returns. But if you are good at tuning these models or fine-tuning these models from ground up, then you should be getting a better model for your use case. But second option I've seen is the parametric efficient fine-tuning, which is not changing the entire weights within the LLM model. It just adds a layer and changes those layers, which means a regular person with a 4-year education learning physics as a extra course or a subject in a university, and then reading those research papers. So that's the analogy I want to bring up, saying that it's just a domain that it is being trained on, and a domain that is added to the LLM so that it can read the research paper and provide a better understanding and nuances within the research papers. So let's move on to the differences between fine-tuning within Amazon Bedrock versus Amazon Sagemaker. So Amazon Bedrock, as we know, it's more of a wizard-based approach. You clicks, you should be able to kickstart the fine-tuning. In Amazon Bedrock, as long as you have the file in a JSON-L format, stored in S3 location, few clicks, you'll be able to get the model fine-tuned. And most of the models are vendor-based models, proprietary models, and some of them are trainable, some of them are not trainable. So this is something you got to keep in mind. If the model of your choice is not trainable, it's going to be difficult. You probably have to move on to a different model in Amazon Bedrock. And the more as time progresses, they're adding more models to Amazon Bedrock. And whereas in Sagemaker, You can pretty much find the open source as well as the proprietary models. Some of the proprietary models, some of them are like Claude is not available on SageMaker, and you can fine tune in various different ways. There are like fine tunable ones, there are like PEFT tunable ones, and you can choose the instances that you want to fine tune. You want to use a lower instance to save cost, but number of hours might increase. You can go with that option, or you want like a highly fast tunable option when you can pick the GPUs within SageMaker, and not just the instance. You can also choose how you want to train it. So you can also train it using HyperPod. You can train it using SageMaker containers, as well as you can pick and choose AWS native chips as well. Trainium chips can be used to train to save cost because it's a good price to performance ratio. And they have very advanced MLOps features to train. Can trigger training based on monitoring metrics, or can trigger some of the training and stop and start the training in a customized manner. Whereas there is a lot of heavy lifting in SageMaker compared to Bedrock. Bedrock takes care of all these MLOps behind the scene. Again, depends upon your use case and the maturity of your team to see which is the best route for their fine tuning. And I also want to highlight, fine tuning is expensive, resource intensive. And please make sure that if you are trying some of these techniques on SageMaker, please turn off those instances as soon as the fine tuning is complete. Like I said, it might cost around hundreds to thousands of dollars to just fine tune the model. So in my video, I'm not going to hit the fine tune. I'm just going to like kickstart and then cancel it. It's expensive, and also warning the viewers that this may just by watching should be good enough. Unless you want to build those applications and fine tune those models. So without much talking, let's get into the session. So log into the AWS console and move on to the Bedrock page. And then under the model access, ensure that you have access to these models. I'm going to ensure that I have access to all the models that I prefer. That looks good. Then go to the custom models, and that's where you can see or you can train those model into your customized model. And there are a few models that I played with and fine-tuned with small data sets. And then there are like two options when you customize a model. One is the fine-tuning option. This is where you tune, change the weights, then get a trained model. And the second option is create continued pre-training, which is more of sending a corpus of data so that it has information about the data set or the domain that you want the model to be trained on. So let's say if you want the model to understand the financial data, you just send a big block of data to the model, and it reads the information, understands, and then adjusts the weights accordingly. So in this demo, I'm going to show the fine tuning option. Like I said, not all the models are fine tunable. You can see in this also whether some of these models are fine tunable. In this example, I'm going to pick the text G1 Lite, and then I'm going to give a name to the model, to the job. You can also deploy it on a VPC. That's recommended, but only if you are in a production one. But for this demo and playing with it, you don't need to deploy it on a VPC. Can choose the S3 location. I have an S3 location where the test.jsonl format is where I stored my training file. I can also provide the validation data sets output, and you can pick and choose. So the validation data set is optional. If you have a validation set, it's good. You can give the S3 location. And next comes the hyper parameters. You can choose the epochs, number of times you want to iterate with the training data and the model. And the higher the epoch, the longer it trains and higher the cost. And batch size based on the sample size. You can give the higher batch size. You might miss the best model configurations or the training. So play with the batch size and learning rate, understand the model, read the model card, understand how the model can be tuned, and play with those learning rate as well as the batch size. And once the training is complete, it needs an output location, and that's when you can go here and provide an output location. So this provides the information about the training, and you can also use an existing role or a role that you can create. So I have a role already created, Bedrock finding, and then I hit the create fine tuning job, it kickstarts the whole fine. The model is fine-tuned. It looks something like this. You will have it deployed across an endpoint, and that endpoint can be used to play with. Like I said, this is expensive and it takes time. I just put like 2 epochs, kept the learning rate same, batch size same. I didn't make much modification. And finally, the model is ready to be queried by the Bedrock agent. So keep in mind, there are some limitations around what models can be trained, similar to Sagemaker. There are a couple of options where you can import these models nowadays. Once you fine tune, you can import these models in the import model option. And also you can purchase the provision throughput. When the model is hosted, you can get the right throughput for your needs. So this is how it works in Bedrock. So let's move on to Sagemaker and see how easy is Sagemaker. Like I said, I'll be going only through the wizard-based approach so that it's much easier to understand. And there are obviously programmatic routes for both Bedrock and Sagemaker. Sagemaker might have some advanced MLOps options, metrics and model monitoring options. But otherwise, let's just explore the wizard-based option in this session. And in the later session, I will explain how programmatically it can be done. So going to the Sagemaker console, I like to go through the studio, opening the studio here, personal space, studio is up running. So once the studio is up running, you can go to the jump start. And usually I prefer smaller models. So we can start with trainable models. So you can check this box right here. It shows only the trainable models, and within that I'm looking for GPT-J6B, which is the smallest model, one of the small models. And then you got 3 options. So this is a wizard-based approach, and there are like programmatic approach that you can do, but in this session I just want to focus on the wizard-based approach, which will be apples to apples comparison between Bedrock and Sagemaker. So once you click the train, you can have the location of the model where it will be stored. So there's a sample data as of now, or else you can enter the data set that you prefer. So I'm just going to use the training data set. Epochs, like I said before, number of iterations that it needs to go through, the data set, the learning rate, batch size, evaluation batch size, if you're evaluating warm-up ratio, instruction trained model false, because this is something to say you're providing an instruction and the model has to get trained according to the instruction, which is more labeled data set. And other important question is whether the model is trained from scratch or not. So you have options like true or false. Most of the time, true or false is the best option. You don't want to train unless you have a very definitive use case, which needs to be trained from ground up. And next comes the precision. So FP16 is the smallest model, and you can also do the FP32 based on the precision needs of your model. You can pick and choose, but 16s are fast unless you need a level of precision in your model response. That's when you go for F32. Otherwise, F16 models are very efficient and highly performant compared to the FP32 models. And then comes the deployment option. So they provide you like a couple of options, like suitable instances there. These are like pre-picked instances, and you can go up in the ladder of instances and get a better performance. Otherwise, you can stick to the lowest instances possible. And have all these default buckets, IAM role that you can pick, or they will pick it for you. And VPC or not VPC, that's a choice. Similar to Bedrock, they have the similar option. And then you have the name. So the overall, what I see the difference is you have more models, open source models, and different models have different hyperparameters that you can tune. And also you have some trainable data sets available, and all the models are stored in a S3 location, much easier to gain access to. So overall, this is what I see around GPT-J6B. And then we move on to other models that we have. I just want to say trainable Mistral 7B. So let's see how this training looks like. So overall, everything else looks the same except the hyperparameters. So this is something only PEFT tunable as of now. That's probably a strategy from the vendor. And the PEFT tunable, there are typically 2 options. One is the adapter and LoRa, but this is only LoRa options available here. And then you can say whether it's a chat data sets or not. Rest all the hyperparameter remains the same except few LoRa hyperparameters here, so that you can explore. These question mark gives you more information about each and every hyperparameters in the training job. And then again, you have different options here. You can see much more bigger machines compared to EPTJ6P because its model's getting bigger. So you need bigger instances here. So you have the options to pick the instance based on the throughput or the performance that you are choosing. Whereas Bedrock, everything is done behind the scenes. You don't have to worry about the instance, or you don't have to worry about the throughput. You purchase a certain throughput and you get those throughput. So that's the difference. So you are doing more heavy lifting, right? So once these models are up running, even if you use or not use, these instances are charged. But there are a couple of other options in Sagemaker where you can kickstart a model, and if there is a failure, it automatically stops the instance, and then you can retrieve or restart when you are back. So there are more options. This is just the apples to apples comparison of Amazon Bedrock and Sagemaker. And like I said, there are more options around the deployment. There are options around the pipelines, model monitoring. So there are a little bit advanced MLOps options when it comes to Sagemaker. And you can pick and choose based on your use case, based on MLOps needs, your requirement needs, based on your usage. If your team is very mature in the ML area, you can definitely choose Sagemaker over Bedrock. Otherwise, there is a significant heavy lifting when it comes to Sagemaker compared to Bedrock, but for good reasons. So with that said, I'm wrapping up the session. And in the next few sessions, I'll cover deep dive into some of those fine tuning, MLOps part of Sagemaker, also the hyperpod, which is an interesting concept that's recently come up. The hyperpod cluster, these can be used to train the models, and we have the Trainium chips to democratized training and to be cost effective. With that said, I'm wrapping up the session. Thank you for watching the video. If you like the video, please hit the like button and subscribe to my channel for the latest information. Signing off, John.